Hi there, this is video 4.2, solving quadratic functions by graphing. So in this lesson, our concepts are we're going to solve quadratic equations by graphing, and we're going to estimate the solutions of a quadratic equations by graphing. So let's go straight. We've got four vocabulary words. Let's go through them, and then we'll get right into the lesson. So what is a quadratic equation? It's our quadratic equations that are set equal to zero, equal to some value, and usually we do 0. What is standard form? Standard form is very important to know. It is ax squared plus bx plus c equals 0, where a cannot equal 0 because if you do, then it's going to be a linear function. And a, b, and c are integers. Just like a linear equation, a, b, and c have to be integers. So it's really important that you know that. The next two words are important, but you need to really understand what they mean. So we have roots and 0. So root is just a solution of a quadratic equation. Zeros are a method for finding the roots of a quadratic equation by setting it to 0. They are also called the x-intercepts of the graph. So if you see the word roots, zeros, solutions, or x-intercepts, then what we're asking you to do is we're asking you to find where does a quadratic equation cross the graph at these points. So root, 0, solutions, x-intercepts. I'm not going to ask you specifically the difference between them because basically they're the same thing. The only difference is this one is going to be a coordinate because it's the x-intercept is a coordinate. So it's going to be x comma 0. All right, so let's look at what we're trying to find. So if we look at this is a graph of a function. So we want to find the 0. So here it crosses the x-axis of -2 and +3. So we can say that the zeros of the function are -2 and 3. We can also say that the roots are -2 and 3. And we can also say that the solution is -2 and 3, as well as we can say that the x-intercepts are -2, 0, and 3, 0. So let's look at the first example. And I don't like this method, but we'll go because the book says. So it says solve this by graphing. So first of all, we're going to make a table right now. You're going to learn some other methods. Just be patient. Let's go through the process and understand how it all relates. That's why we're doing this, even though it's mundane and we're going to use other methods going forward. But right now we have to understand, okay, worst case scenario, we can make a table. We don't have a calculator, our calculator fails, we don't remember how to put it in vertex form or other forms, and it's in standard form. Well, we can simply just make a table. But the first thing you have to know is you have to remember the -b/2a formula, because that's going to be important, and that's what we're going to use. So in this equation, let's identify a is 1, b is -3, and c is -4. So we're going to do -3 over 2 times 1, which is 3/2 or 1.5. Okay, then we're going to do f of 1.5 into the equation x squared minus 3x minus 4 equals 0. Okay, so we're going to put it into this equation here. We're going to do f of -1.5. Okay, you put it in. The book doesn't tell you to do that, but you should do that first. So it's -6.25. So when you look at your table and how they came up with it, they used the vertex -1.5 over -6.25. And then they made points around it because we know it's going to open up. And so we're going to just, it doesn't matter, but we're going to get points to the right of that, points to the left of that. So they just picked some random points, and they end up seeing, and you can see where y is 0. So remember, the x-intercept solutions roots are zeros. Y is going to be 0 of the function, and you've got y 0 here at -1 and 4. Therefore, -1 and 4 are our solutions. And here they wrote it in set builder notation. So pause this and try doing it with graphing 1a and 1b. Right, so now we're going to say what types of solutions are we going to have with quadratic? Well, you can have one solution when the vertex is on the x-axis, whether it opens up or down. two solutions if it goes through, if it's below the x-axis and it opens up, or above and opens down, then you have two good solutions. Or you can have no real solutions, and I'm going to be a stickler on this, so make sure you write this down and you note it, that if there is no solution, don't put no solution or empty set. You need to put no real solutions, because we're going to learn in a week or so there are such things as imaginary solutions. So there can be complex solutions, but that's equivalent to no real solution. So you need to make sure and say, because there is a solution, it's just not a real solution. So let's look at example 2. So here again, they want us to graph. So we've got 14 minus x squared equals negative 6x plus 23. So the first thing we're going to do is we're going to put everything to one side. So we use algebra, we add x squared to both sides and subtract 14, and we get this equation right here. So then we need to find what is our vertex. So again, we're going to use the formula negative b over 2a. And when we put that in, we get negative 6 over 2 times 1, which equals positive 3. And when we do f of 3, we're going to get 0. So our vertex is 3, 0. So we're going to work around the vertex and make a table. We're going to find x's to the right of 3, so they chose 4, 5. And then to the left, 2 and 1. And we did f of. And that's how they got these y coordinates. And we plot them when we see that the vertex is on the x-axis. So we have one solution, 1, 0, 1 root, 1 x-intercept at 3. So pause this and do the guided practice 2a and 2b. Okay, so let's look at no real solution. So here they want us to use a quadratic equation to find two real numbers with a sum of 15 and a product of 63. Well, the first thing we have to do is we actually have to write the equation. So we said the product of a number x times, and we know that this one is going to be 15 minus x is equal to 63, because they tell us that the sum of use a quadratic to find the real numbers with the sum of 15. So this is how we got this one. So we said x plus y equals 15. And we solved for y, and we got y equals 15 minus x. And we said the product of y and x is equal to 63. Well, we know y is 15 minus x, so we replaced y with 15 minus x. So now we're going to just distribute. So we have 15x minus x squared equals 63. We're going to move it all to one side, and we end up with negative x squared plus 15x minus 63 equals 0. So now we need to find the vertex. If we do the negative b, so we're going to get negative 15 over 2 times negative 1, we're going to get 7.5. And when we do f of 7.5, we're going to get 6.67. I believe it was negative 6.67 is what we get. Yes. Okay, so this is our vertex, 7.5, comma negative 6.67. Okay, without even making a table, we can go graph it. We know it's going to open down, so say this is 7.5, and this is negative 6.67. So this is a vertex because it's A is negative. We know it's going to open down, so guess what? There is no solution. It doesn't cross the x-axis. Therefore, there is no numbers that this could make this statement true. So there's no possible way to take the sum of two numbers who equal 15 and the product of the two numbers to equal 63. There is absolutely no way. There's nothing that's going to make it true. So pause this and try guided practice 3, and you'll have to make your own equation just like we just did. Okay, so the last thing we're going to do is we're going to estimate solutions. So this is really important that you understand this piece of the problem and understand where the solutions lie. So let's look at, we're going to make this table. and it goes through 14. So we're going to do these by 2. 2, 4, 6, 8, 10, 12, 14. And then 2, 4, 6, 8, 10, 12, 14. And then these we're going to go by 1. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to take that table that's on our notes and let's plot these points. So negative 3, 12. Negative 2, 3. Somewhere right here. Negative 1, negative 6, 2, 4, 6. 0, negative 2. 1, comma 4. 2, comma 8. And 3, comma 14. Somewhere up here. So we notice, I know I didn't do the prettiest job, but you get the picture. We notice, and you look at the table, and you're looking at the y values, right? Because this is what we're talking about. So here, this one has a positive, okay, and it's at this coordinate here. And this coordinate has a negative, right, the y value. So it goes from a positive y value to a negative. So to do that, it has to cross the x-axis somewhere right here. Well, because it's between negative 1 and negative 2, without using calculators or other methods of algebraically doing it, we don't know this value. We know what we do know is it lies between negative 1 and negative 2. Likewise, here, you went from a positive to a negative, so it had to cross right here. Let's see, we can make a different color. So this is where they cross. So we don't know this value. Again, it's between what? 0 and 1. So our solutions are between 0 and 1 and between negative 2 and negative 1. Without a calculator or without doing it algebraically, that's as best we can do. We're estimating. So let's look at example 4. That's all we're going to do is we're just going to estimate. So it says solve by graphing. If roots cannot be found, state the consecutive integers. So the first thing they did is they made a table. They found the vertex, which is, I believe it's 3, negative 5. And then they found points to the right and to the left. Okay, so you do understand that these are our x values and f of x are the y's. When we put x into this equation, this is what we get. So we plot this, we'll note, and we don't even have to plot this. We can just look at the table. When does it change from positive? And I wanted you to see the table, the graph, because when it goes from positive to negative, or negative to positive, then it has to cross the x-axis. So let's see where we have a sign change. Oh, we have a sign change here. So our first solution is between 0 and 1. And then negative, negative, negative. Oh, we go from a negative y value to a negative 1 to a positive 4. So it crosses. So between 5 and 6, these are the x coordinates, is where our second solution is. So that's just an estimation. And we don't need to graph it. We don't need to find it when they just want us to estimate. So you're going to have to know how to estimate without using a calculator and tell me how you knew that. All right, you'll have to explain it. So pause the video and do guided practice 4. All right, we're going to skip guided practice, or the example 5. What they're doing is you can actually use a table, and we'll look at this in class because I want us to do it together on our calculators, and I want to be able to show you and walk around and make sure you're doing this correctly. So we'll do example 5 in class. Let's go straight to example 6. So it says a package of supplies is tossed from a helicopter at an altitude of 200 feet. The package's height above the ground is modeled by this equation. H of t equals negative 16t squared plus 28t plus 200. Where t is the time in seconds after it is tossed. They want to know how long will it take the package to reach the ground. Well, we can actually use our calculator here to find the solution. So we could graph it, yes, we could that, but we could also put it in our calculator. So if you notice on the video notes, I put the steps. So the first thing you're going to do is you're going to go enter the equation. Make sure it's in standard form. which it already is. So we're going to do y equals, enter our equation. Then we're going to hit second trace. We're going to hit 2, okay, because 2 tells us the 0, right? That's what we want. We want the 0. Then you're going to make sure, let's look at this. You're going to make sure that the cursor, so here's, it says, when does it hit the ground? Well, we obviously know it's not going to be this side because we can't have negative time. So it's when the height is 0, we want to know at how many seconds will it take. What is the x coordinate? Because x is time, seconds is the x-axis. So our value is here. So we want to make sure our cursor's to the left, so our cursor's above the x-axis. So if it's way over here, make it, or way down here, put it to right here. And then hit enter when it says left side, and then move your cursor. It'll say right side. Put it somewhere down here to the right of the point, hit enter. And then it'll say guess, hit enter again, and then it will give you the value 4.52. So approximately at 4.52 seconds is when the package will hit the ground. All right, so stop the video, do guided practice 6, and we'll see you in class.